Hello. So going to take you through bearing and mainly through cosine and cos rule, especially with these questions that have been disturbing you. Now we have a diagram here, and we also have another diagram at the bottom. I'll just be sliding up. So in this, we'll be using our calculators to solve some of them. Remember, we are using cosine rule and sine rule, both in areas and also in finding the various lengths that are in this diagram. You may also have to use one decimal place when we are dealing with rounding numbers, especially when we get numbers with more than one decimal place. So the diagram shows two fields on horizontal grounds. So we have two fields here on horizontal grounds. So there is field A. Let's call this one field A and this one field B. So A is due south of D. This point A is due south of B. In such a case, we'll have to rename this one different name. Let's call this field X and this field Y. So A is due south of D and C is due east of D. Due south means perpendicularly south. That is 90 degrees to the south and 90 degrees to the east. So we are now going to calculate the distance DC. It should be noted that these are some of the clear notes that we should do, that the point DBC is a right angle. That point DBC, this point, this is a right angle. Therefore, when we are finding the value DC, we are just basically looking for the hypotenuse of a right angled triangle. So let's check at the hypotenuse of a right angled triangle. So let me draw this triangle. It's better if it's here. Yeah, it's a right angled triangle. I'm just going to draw it upright so that it's visible clearly. Just a sketch, not to scale. So we have our point. We have this point here. This is our point B. Very important to start with where the right angle is. We can put our D to the top and our C to this side. So some of the angles we need at D, this angle is 30 degrees. And the distance is 102 meters. So what we are looking for is we are looking for the distance DC, this distance, which is our hypotenuse. Perhaps it should be remembered that it's not a must for us to find it in the Pythagoras theorem form because we are missing one side, but we can use the sine way. So let's remember that when we are looking at this, we have the angle and the side. So we have this angle and the side. So this is the hypotenuse, and the side that we've been given is the adjacent side to 30 degrees. Therefore, from SOHCAHTOA, I'll have to write it here. So we are looking for something that we are going to have the hypotenuse and the adjacent together. So the first one is opposite and hypotenuse. We don't really need sine. For the cos, it's adjacent and hypotenuse. That is exactly what we are looking for. So we are going to say cos theta. And for this case, our theta is 30 degrees, is equals to the adjacent part, which is 102 over hypotenuse. That is what we are looking for. By the idea of making x the subject of a formula that I taught you, therefore x can be 102 divided by cos 30 degrees. In other words, x is, if you use your calculator, whichever type of calculator you're using, as long as it can solve these trigonometric things. So if you divide it by cos 30, you're going to get your value as 117, 117.7 and 79 and so many other things. So we're not going to truncate, we are just going to round off to the nearest decimal place, perhaps 117.8. Remember, when we're rounding this one, we're adding 1 here. Now, let's check out the other one. The other one is calculate AB. We are calculating AB. AB is in a different triangle. Now we are from here to here. We're calculating AB from a different triangle. So how do we solve this? We only solve it from cosine rule or the sine rule. But because in this case we only have one angle, let me just draw it. I have to draw that. That is just a sketch. These are 3-mark questions, so you have to treat it to the attention it deserves. So this is 60 degrees, and then the distance we have here is 110 meters, and we also have 102. Now, these distances we're calculating them will help us solve a lot of questions. So that's why we have to calculate them. These are procedural questions in paper 4. So one question leads you to another, or if it doesn't lead you to another, there's a place where we'll need to use the values you got from a previously calculated question. Now, when you have the angle, I'll label them as A. This one is our D. This is our A, and this is our B. Should be remembered when we are dealing with trigonometric signs, one of the things that we need is that if this side is D, then the opposite side to that angle becomes our lowercase d for the formula purposes. If this is A, this is the A, and this is the B, like the opposite parts. You can see these are the opposite parts. So that's how you do them. Now, let's find the values. So when we are looking at this, we are looking for the distance D. We have one angle, so we can just choose to use one angle and one side. So we are going to put the formula here. Let's just put the formula in terms of D instead of using A. So our formula would be, because we are looking for the point D, so D squared is equals to A squared plus B squared. Remember, this is cosine rule, minus 2AB cos D. This cos D, the angle D that we have. So D squared is going to be, now our A squared is 110 squared. You really don't want to write everything. You just have to say 110 squared plus the B squared, which we have, so our A squared appears to be not 110, it's 102. Remember, A is the distance here. So it's 102. So we have 102 squared plus, now the B squared, which is 110. Now we use the 110 squared, and then we take away, we have to introduce the bracket sign here for the purpose of calculation if you are putting it in the calculator. So we have 2, and then multiplied by the value, which is A. Our A is 102, and our B is 110. Then we are still going to multiply it by the cosine of the angle 60 degrees. So we have to do this one and put the answer in the calculator. You can do the first ones in the calculator. Perhaps this one can be done in the calculator and this one in the calculator. Then you just subtract them. So D squared is equal to, if you insert this one in the calculator, 102, if you have a calculator, you can just insert it. So 102 squared plus 110 squared is 22,504. We now take away, we also insert the other one in the calculator, which gives us 11,220. So we do the difference, like we are taking the value which we had, which was 22,504. You subtract the answer that you got, which was 11,220. And this one gives you D squared as 11,284. Remember, we take the square root in both sides so that we have the value of D. So D will be the square root of 11,284. Still, the same can be done in your calculator. Don't strain your brain for unnecessary calculations. That one gives you 106.226 blah blah blah. So we said we stick to our accuracy. We are sticking to an accuracy of 1 decimal place. So if you round this one to 1 decimal place, it's going to be 106.2 meters. So the value of D is also known as AB, 106 0.2 meters. Should we remember that we also had calculated DC, which was 117.8 meters. We really don't have the value BC. Perhaps maybe the questions really do not need them. But then because in case we meet a question which needs us to find BC, we can find it. Or you can use the Pythagoras theorem or even the trigonometric rules to find the value of BC. So we go to the next question, which was still this part of the question. Remember, we are dealing with sine and cosine rules. So we are supposed to calculate the total area of the fields. So we called this one field X. This one we called it field X. And this one we called it field Y. So we have to calculate the area of X and the area of Y, and then we add them together. Now, we can have one formula just to handle all of them, but then because we have space, let's deal with one at a time. Sine rule works here. The area, when we use the sine area, let's start with area of X, which is, we can use it as area is given by a half AB sine theta. For this case, the value AB, this one represents, let me write it in a different form. AB sine theta. Theta is the angle between AB. So in case we are dealing with this side, the angle we have is 60. So we are dealing with the sides which are just adjacent to that 60. So in this case, we'll have to deal with 100 and then 2. So you can't use the side which is opposite from 60. That is very far away. Not even this side should meet or should intersect at that angle. So this gives us our area being a half. Our side A, we can take 110 to be our side A, B to be 102, and then we multiply by the sine of 60. So we can put this one in the calculator rather than cancelling them out because it's a 3-mark question. So we can just put it in the calculator and see what we get. So we put that in the calculator. This is what we are going to get. 4,858. I'm putting it to one decimal place, so 0.4. So now we find, remember this is in meters, so this is square meters. We also find the area of the second triangle. So the area will be of region Y is given by, I'll change the color so that you don't really confuse them. A half still, the formula is the same, AB sine theta. So we are going to have our a half. Our A is now, this one was 117. Let's check out. This was 117.8. That one was 117.8. So we are going to put here our A as 102. This is the theta we are using. So we have 102 and 117, which are intersecting at 30 degrees. So 102 multiplied by 117.8 multiplied by the sine theta, sine 30. Sine 30 is always a half. So multiply by sine 30. So if we multiply this is what we're going to get. So 3,003.9. Yeah, now so we just take now the totals and find the area. So we have 3,003.9. We add it to the other one. If we add the two, we have to add the two to get the correct one. So 3,003.9, we add it to 4,858.4, and then the total area we're going to get, remember this is the first and the second one, so we add the two and we are going to get 7,862.3 meters squared. Thank you very much. I'll prepare another one for the continuation of this. There is a question missing, which is very important. This one, the bearing one. I'll prepare it and send it direct to you. Thank you.